So on January 10th of this year, about 4 months away, we launched Ultralytics framework. And I just wanted to make that this video, or I mean, a video covering the launch and all of the other things, how we planned it and the demos while we launched, but we were so overwhelmed by the response and all the issues to maintain that I didn't really make this video. But now that we have reached more than 1 million downloads, and the usage is still just going up, I thought I should make this video after this sort of milestone. There are many milestones to consider. Like, we are almost about to reach 9,000 stars, which again in itself is a milestone. But what I wanted to talk about in this video is essentially the story behind Ultralytics repository, why we decided to do this, and the structure of it. So this is useful for anyone who is looking to get into open source, or someone who's looking to work with Ultralytics framework to build on top of it, or just be a contributor interested in contributing, or maybe just interested in how this works. So there are so many things that are different about this release of YOLO. And by the way, if you're not familiar, Ultralytics also launched YOLOv8 a few years ago. I think 2.5 years or 3 years now. 2.5 years. So we built this still continues to be the most famous computer vision repository on planet, and we took a lot of our learnings from here when we decided to build Ultralytics repository. Now again, as you already might have known, that I'm not going to follow any script or any structure here, so I'll just start spontaneously discussing some things. But by the end of this video, I want to cover a lot of angles as to like what goes into building this and how you should plan and project manage this, and in turn you'll also understand how you should go about in contributing to this repository. And then if you're someone who's sort of looking to build on top of this framework, because everyone should, it's super easy. That is one of the most core things that we focused on. And so all of these 2-3 things are the main agenda of mine when I'm making this video. Okay, so let's just go back to YOLOv8 for a second to understand why this repository, right? So YOLOv8 is probably one of the simplest tools out there, yet one of the most powerful tools out there. Like, even I know like people still use YOLOv8 even though like there are better models available, but the thing is, the problem is that you cannot define better. So for some people, better means just higher accuracies and stuff, but the problem is that does not translate to real world basically, and everyone knows that. But we have to use some benchmarks, so we use COCO. But the COCO benchmark is not the ultimate definition of a better tool. A better tool is one that enables you to do something quickly, very rapid prototyping and all of those things. And so it is really important to consider the overall aspect. Now what YOLOv8 does, it eliminates the need to set up your complex processes and stuff like that Darknet did force you to. So this is the very first time YOLO was written from scratch in PyTorch. No other dependency on C++ and stuff like that, so you don't have to set it up a lot. And then simple to use. Okay, we got that part right. And then what is the next part? The next part is to be useful. So it actually was quite powerful, maybe not by a lot of margin, but the ease of use in itself is a big thing to consider. Now a lot of other things also happened there. So a lot of research happening in companies like Meta were focused on accuracy. You see faster RCNN and stuff. No one uses them in the industry these days. And that's evident by the fact that most companies that do data sets, that do training, don't really even mention RCNN models. And so the quality of SSD is that they are very economical. They are very, that's why, and hence they are very, very commercial, right? So all of these 3 things happened together, and then YOLOv8 was born. Great. Again, this in itself is a good case study. Maybe we can do it sometime else. But right? So simply to install it, you just clone it, you just install the requirements, and you just start running inference, you start running training and all of that on your custom data set, and everything is fine here, right? Now the problem starts with, and not even a problem, it's just a limitation here. So that's the thing about simple tools, they do a lot of things really well, but they cannot be extended to do other things, because then simplicity is sort of tinkered with, or let's just say it's traded off with functionality. So now what, right? Now the problem was the most of the usage that we saw in terms of Python usage, right? I mean, obviously the usage except these that we provide here was that people were trying to wrap it in their own Python classes so that they could then package it and use it in their own organizations, or maybe other users can use it, or maybe they just wanted to build R&D stack on top of it and they had to package it themselves. So what we did was we tried to sort of solve that, and that was one of our biggest concerns, because a lot of companies have to already integrate their object detection models in their already existing stack or existing pipeline, and we were just probably making things difficult for them. So maybe some users who actually wanted to use this were not able to use it, or were not using it because they had to do some extra work, which comes to the pip package. Now pip package, we didn't have pip package because we wanted to keep it simple. It didn't really start off as a commercial project, and so then we thought, okay, maybe pip package is the way to go, and we tried it I think a few times, but let me see. So this is August, I think. Yeah. So you see, this is an attempt that I made, all of that, and then you could import YOLOv8, YOLOv8.detect, YOLOv8, or CLI command YOLOv8 detect, things like that. Now this might be ringing some bells if you already have worked with YOLOv8. Syntax is pretty simple, like this. So this is the start of it, right? This is how everything started. I also have an example GoLab. I thought I didn't have it, but anyway, this is the PR that yeah. So you see, this is how you install it. This is how you use YOLOv8 help, you get all these commands, and then YOLOv8 train help, you get all these commands, and then you can simply train using YOLOv8 train epochs, things like that, right? You might have already seen that in YOLOv8 or Ultralytics framework. So this is the basic idea, but we couldn't do this. Like, if we do it, the thing is, if we merge this to main, what happens then? What happens is you get a broken a software that is not backwards compatible, right? So it somehow like breaks all the existing code that is on top of it. A version change that breaks everything is not how the most popular computer vision tool could sort of do a release, right? We couldn't really explain this to user. I'm pretty sure if we tried, we would not be able to, and everyone would be angry because, hey, you broke a system that was running in production and don't really know how much a company would lose in a minute, right? So this is what happened, and we sort of thought to start from scratch, right? We had to start from scratch because we couldn't do it, and it was a big move. How like we were already at 30,000 stars there, and so a company that already has a project that has 30,000 stars would never sort of start another project from scratch. But we had to, because that was the right choice, that was the right thing to do. And so this is how we decided that we'll work on Ultralytics. And so if you look at the issues, you will see some glimpses of what we were thinking of and how we started doing it. So if you go to the last sort of the last page in the issues, you will All right, yeah. So if you go to the last pages, you will see the discussion of how we wanted to do stuff. So we had initial pip structure, we had requirements, all of that, and then we were discussing how the structure should be. I mean, this is like one of those things that we finalized, but we had a lot of meetings and stuff. But essentially, yeah, we discussed from the very first principles of like how we want this to be, and it is to be very simple to use, just like YOLO v5, right? Simplicity is what we were going for in the beginning. And then you see we decided on the drainer structure and data loader structure and all that, and finally everything, when it came together, we decided of doing a few things that had not been done before. First thing was the dedicated docs. Again, docs is a work in progress, it always will be, but we have much better docs than we did at launch, and those docs at launch were much better than anything we had with YOLO v5, because now you have the dedicated sort of reference where if you don't really know what to do, where to start, you just land on the home page and you can just scroll here or in the left pane, you know what to do, right? You know, if you want to predict, just to prediction, you can go to that page, you can learn more about training if you want to do that, and you just want to explore stuff, you can just explore all the tasks, like whatever we support and things like that. So it's pretty much something that we did not have before. And then we also have reference that we're working on, because we worked on automatic doc strings, extraction through mkdocs and stuff like that. So you can just go through and read the code structure, see the code structure and read it completely, right? So we have like 4 top level modules, and then in the YOLO module we have a lot of different things, like engine control. So most of the routines, like prediction routine, training routine, or validation routine, these are just backbones, abstract functions, abstract classes, interfaces, things like that. So essentially this is what we did, and then we felt really good about the design, and the next part was to prove that this is ready for the prime time. So what we did here was we decided to train a bunch of new models and do some R&D on top of it. And we did some R&D, we tried with different types of models, and then what worked best was some anchor free models. And then we finally concluded our R&D and we got some really nice results. This is how YOLOv8 was born. So YOLOv8 is a proof of concept that Ultralytics repository can be used to train powerful models and deploy them, right? So once that happened, we were ready for the release, and then we sort of released this Ultralytics framework with YOLOv8 trained models. And as we expected, a lot of things were not the way users expected, but mostly we got positive feedback. Like, let's say 9.5 out of 10 people were really, really positive about it. And we took a lot of caution in getting feedback. So we addressed those 0.5 out of 10 users by quickly releasing fixes, improving stuff, changing stuff. So now if you come back to a lot of things that you see here were not there at launch, and this is how we expected it to go. Like, it went exactly the way we expected it to go, because initially we started with a new patch release every day, and now it's maybe like every 2 or 3 days, but now it's so stable that we can even push it to every 1 week, right? So that is where we wanted to go. And if you look at some of the things that we support now, for example, if you come to model section, we support okay, yeah, I'm already there. YOLOv3, YOLOv5 headless, YOLOv6, YOLOv8. Obviously we are supporting more YOLO versions, as we are planning to support them. And then SAM, segment anything, we built on top of this our auto annotator feature that can give you your segmentation data set directly, just with the detection data set. You don't have to manually waste time in segmenting data sets. And then we also have real-time detection transformer, which is really exciting. It's NMS free and it's real time. First time that I'm seeing this with transformers. This is done. We are working on trainer, which is like coming really soon. So it has more of a framework like vibe now. And then the next thing that we sort of did was we standardized how you interact with the models. So if you look at the syntax to interact with the models, just like how you would do from Ultralytics import YOLO, you just do that. This Articdata model name, and then this has been standardized. So no matter what the model name you import, the way to run predictions, the data sets that, or the data formats of input that they support, were always going to be the same and standardized across all models, making it much easier for users to learn one thing and then stick to that. And there is really no learning involved here. It's very simple. If you know PyTorch, you know this, right? Essentially that. So this is how it happened. And while we were doing this, we also thought of standardizing the results API. So if you will look at the prediction mode, you'll see we made it super easy to work with a lot of different scenarios. And by the way, this comes to mind, okay, yeah, the stream mode, right? Stream mode is something that we built after launch also. So the streaming mode is something like this. With YOLOv8, it was a command line tool, so the results were never saved in the memory. Right? You run something and then you just free the memory by just letting the variable override itself. But when you're working with Python interface, you might need to accumulate results because you need to do some extra calculations after that. So we built a streaming mode that if you run a video, you can pass stream equals true. It will, instead of giving you the result and storing it in a list, it will give you a generator. So you just populate the value when you need it, and then it just takes the next value just as an iterator would. So we have a stream mode. It's so simple to use. Just pass stream equals true and you will never run out of memory because it just runs frame by frame. And then it comes when that makes me think about the results API again. You have results, a bunch of tensors, bunch of lists, you don't really know what to do, which is why we built this high level results interface, which is you have a result, you can get boxes simply. We just focus on simplicity so much, and this is why everyone likes it, right? These are the sources we support. We support a lot of sources. We support almost all the sources you can think of, like image, URL, screenshot, of course Python, pillow images, OpenCV, NumPy, Torch, anything, right? And then the arguments are super easy. And then working with results, like you get a result, you do results.boxes, you get the boxes. You can send them to CUDA, you can send them to CPU. These are not tensors, but these work like tensors. So again, the focus to detail here is because users coming to this might already be familiar with PyTorch. They have to be. And so if you're using Python interface, so you just learn that once and we just replicate here, right? So again, the boxes in itself is a class. So you run a result, you get a list of all the frames, you select first frame and then get the boxes. And then it's so simple to int and convert them. Boxes dot the format name, and it will give you that format, right? And again, this is also done with very much detail to attention, because what happens is we don't really calculate these values ahead of time. So it's like when the user calls it, we calculate it and cache it. If you have done some dynamic programming, it's like memoization. But yeah, it's not calculated ahead of time. But no matter how many times you call it, it's not going to compute it multiple times. So it's not going to slow down. It's not going to take more memory. And then same thing with masks. You get all these simple formats. Probabilities is for classification, and then plotting results is super simple as well. Like you just do result, the frame, get the frame that you want to plot, and then do plot. That's it. That's pretty much it. And then we accept so many arguments where maybe you just want to plot boxes and not the masks. Maybe you just want to plot the masks and not the boxes. Things like that, right? And yeah, streaming source is an example for streaming a webcam or something like that. So this is pretty much how this is, right? Now, this is the introduction to what Ultralytics framework is. Now, we've left out a few things, like we left out some data sets. So, with this, you can know how to make your own custom data sets. So, for example, detection, we have the detection format, and then we have how to train a detection model from Python and command line interface. Then maybe you have a data set in Cocoa format, how to convert that. So we have a built-in converter for that also. So this is how you convert a detection data set from Cocoa to YOLO format. Then same with segmentation, we have the format, we have the training example, we also have how to convert that into a Cocoa data set into YOLO, and then we also have auto annotation for segmentation through SAM. And then the same thing with pose, how you train and then how you convert it. So this is like a brief overview. Again, the expectation is that you already know what this is. You already have used it maybe once or twice or heard of it. So that's why I have not gone through entire quick start where you can start locally, use with CLI, and then use with Python. I assume that you all already know. Okay, and yeah, so the thing is, this video just covers the background of the story of how this came about to be, and then the next part essentially will be the code structure, because I think I've already spoken enough. This video might be a bit longer and don't really like making long videos, and so I'll break it down into two. So the next part will be about the code structure and how you can actually go about reading the code and understanding and sort of utilizing it for your own projects, building on top of it, maybe new model architectures, and also how you can then go from there to making contributions in the Ultralytics YOLOv8 repository. Okay, that I think is pretty much it for this video, and I will see you in the next one. Thanks. Bye.